Hello and welcome. This is the first video in a series of 4 videos which are aimed to help you with the necessary mathematical skills for the Micro for Business module. In this first video, we are going to recap the basic mathematical skills that are useful for this module. We are going to cover the following topics. We are going to talk about how to read mathematical notation. Then I'm going to introduce you to the special delta notation, which is notifying change. Then I'll show you how you can use the scientific calculator. We're gonna look at some percentage calculations, a little recap on negative numbers. We'll go into the concept of elasticity and calculations around elasticity, and then how to work with tables, because there are some special tables that you need to be familiar with. So, how can we read mathematical notations? If you look at the slide, there are quite a few different ways of noting different concepts in microeconomics. If you look at the first line, P0, P1, Q0, Q1, in mathematics, every letter means something special. For example, in microeconomics, when you see the capital P, that usually refers to price, and the capital Q usually refers to quantity. But what is the purpose of the little 0 and 1 in the subscript? Well, using different notation in the subscript, we are notifying that we're talking about different prices or different quantities. For example, P0 could be the starting price and P1 could be the final price. Similarly, for the Q, Q0 could be the starting quantity and Q1 could be the final quantity. In the second row, when you have got pairs of quantities and prices in a bracket, this is usually the mathematician's way of talking about ordered pairs. So in these ordered pairs, the order is important. In this specific notation, price always comes first and quantity always comes second. It's very similar to the coordinate system, when x coordinates always come first and y coordinates comes second. So if you just look at the number, the 512, knowing that this follows the price quantity order, then I can say that for price 5, I can sell 12 quantities. In the third row, if you look at it, it says Px equals F bracket Qx and Py equals G bracket Qy. What do we mean by this? Well, this is the mathematical way of showing that the price of good X is a function of quantity of the same good. In this specific notation, we haven't actually detailed what kind of function is this, but we just know that the price of product X will depend on the quantity of that same product. How? We would need to give in more details somewhere later. If I look at the Py, then I use a different letter there, G. G follows from F in the alphabet. So this is the mathematician's way of telling you that the price of good Y is a function of quantity Y, but this function is different from the function that I used for good X. In the next line, second from bottom, Qx equals F bracket Px, Py, Pj, M, A, ... This is the mathematician's way of showing you that the quantity of product X is a function of many different variables. So, how many products I can sell of quantity X would depend on the price of X, would depend on the price of Y and the price of J, which are two alternative goods, M, which is usually the income, and A could be some other variable. The ... in this case means that there are a lot more other variables following which are not necessarily important in this very specific case. In the last row, in Federica's lectures, you might have seen this QXD quite often. And by now, you should be familiar with the fact that this is her way of showing you that now I'm talking about the quantity of X which is demanded. Now let's talk about the delta notation. The delta notation in mathematics is a specific way of showing about the change. So whenever you see this delta, you always have to think about change. So how do we actually calculate the change? So when I write delta x equals x2 minus x1, what do I mean by that? Well, x is some kind of quantity, some sort of product, can be price, can be quantity demanded, can be income, anything. And in mathematics, when we talk about numbers 1, 2, 3, 1 is usually the initial price or the starting price, 2 would be the final price. So the change in any quantity is always the final minus the initial. So far, nothing too complicated. But in some calculation, you may have come across with change being positive or the change being negative. Now, what's the difference in here? Well, if the change is positive, that means that this x2 minus x1 is positive. So the final price is bigger than the initial price. So positive change means that there has been a price increase, if we're talking about price or some kind of quantity increase. Now, what does it mean for me if I'm talking about negative? Well, if I end up with a negative here in the difference, that means that x1, the quantity I'm taking away, is the bigger one. So that means that the initial price was bigger than the final price, if we're talking about price, or the initial quantity was bigger than the final quantity. So in this particular case, we would be talking about a price fall or some quantity fall. But the importance in here is that if the change is positive, we're talking about increase, and if the change is negative, we're talking about a fall or decrease. So let's look at an example. So demand changed from 3,575 to 3,277. So what is the change in demand? So I want to calculate the change in demand. Demand is Q in economics. So I need to calculate the final demand minus the initial demand. Now looking at that sentence, change from to tells me which is the initial and which is the final. So the initial price, the initial quantity was 3,575 and the final quantity is 3,277. So the change will be, picking up the calculator, just quickly type in 3277 minus 3575. So pick up the calculator. 3,277 minus 3,575 is equal to minus 298. Now, what does it tell us? Well, it tells us the obvious, which we would already know by just looking at the quantities, that the demand has dropped from 3,575 to 3,277. So remember, every time you see a negative change, that means a fall, a decrease, or a drop. We already made some use of the scientific calculator, but let's just make sure that we know exactly how to use it and why is it better to use a scientific calculator. So when you're using a scientific calculator, the order of operation, which is sometimes referred to as BODMAS, is already built in. So when you're using a scientific calculator, you don't need to really worry about which calculation should be done first. The calculator knows it. So as long as you give the calculator the correct instructions, it will carry out the right calculations. Not like an ordinary calculator, such as this one. Because with the ordinary calculator, it just follows a linear order. So what you tell the calculator to do first, it will do it first. So if you type in to do subtraction first and then division, it will do the subtraction and the division. But if you change the order around, it will do the division first and then the subtraction. However, in BODMAS, that's not always the case. So if you were to carry out a calculation, 5,300 minus 5,700 divided by 5,700. If you had an ordinary calculator, you would need to do the subtraction first and then the division. But with the scientific calculator, you can type it all in one go. In the scientific calculator, there is this button, which is the fraction button, and then you just type into the top 5,300 minus 5,700, and then come down using the arrow buttons and then type in 5,700 and then quickly hit the equal sign, and it gives you straight away the answer. Obviously, in mathematics, fractions are always more exact answers than decimal numbers, but in finance, in economics, in everyday life, fractions are not as useful. So if you wanted to calculate the decimal equivalent of this, you need to press the SD button. So this one is roughly equal to minus 0.07 to 2 decimal places. Sometimes you need to do calculations like the second in the row, which could be an average of 2 amounts. So again, to be able to calculate this, I need to start with the fraction, type in 550 plus 600, come down, type the 2, and then hit the equal sign. Again, it gives me the 575 quite quickly. Again, if you were to do it in an ordinary calculator, you would need to do this calculation in 2 stages. First, find the answer to the sum, and then the answer for the division. Now, in the middle row, I've got 3 different versions of more or less the same thing. Now, what is the difference between these 3 using 15 and the square? Well, 15 square is just simply the square of 15, which I can calculate quickly with the calculator. Type in 15 and then use the square button, and that gives me the 225. But what is the difference between using the bracket and not using the bracket? Well, brackets are priorities, so that's telling me what I need to do first. In this particular case, it's telling me that I need to square the minus 15, not just the 15, the minus 15 altogether. So knowing that squaring a negative number is the same as multiplying negative by negative, I'm kind of doing away with the negative sign. So how can I tell this to the scientific calculator? Well, I type in the bracket, then the negative sign, the number 15, close the bracket, and then hit the square button. And I'm expecting to have a positive answer, and exactly the same as this answer. So that's again 225. Now what's the difference in here? Minus 15 square. Now look at here. Because there is no bracket here, I need to do the squaring first, because that's a higher order operation than the negative sign or the takeaway. So in this particular case, I will need to square the 15 first and then have the negative sign in front. So the negative sign in this case would not change. So the answer I would expect here to be negative. Now let's see what the calculator says. And yes, indeed, it's minus 225. So be aware that the bracket, just by placing brackets into different places, I might alter the final amount. So watch out for brackets. And then in the last question, in the last calculation, QXD equals 2,500 minus 0.4 px plus 0.5 m plus 0.3 py. Now, before I go into the calculations, one thing that you need to be really familiar with is what these specific letter combinations actually mean in economics. Well, as we mentioned it in a previous slide, QXD means the quantity of product X demanded. But PX, what does it mean? P, as I mentioned, is usually price, so it would be the price of product X. Capital M is the income in most cases, and PY is the price of product Y. So to be able to calculate the demand for product X, I would need to know the price of product X, the income, and the price of product Y. Handy that it has been given in the question. So the income is 3,000. The price of X is 50. And the price of Y, which is an alternative good, is 45. So how can I calculate the quantity demanded of X if I know these values? So all I need to do now, replace the letters with the corresponding numbers. So QXD equals 2,500 minus 0.4 times PX is 50 plus 0.5 times M is 3,000 plus 0.3 times PY is 45. Now, one thing in algebra is that when I multiply a number with a letter together, I never write out a multiplication sign. But when I need to do the same thing, multiplying numbers together, I always have to write out a multiplication sign. Okay, so there is an X in here, so that's an X, meaning a product. But this one here is a multiplication sign. If you are from Europe or some other countries, you might be familiar more like using 0,4, not decimal point, but decimal comma, and using a dot for the multiplication sign. But that is not used in England, so this is the right way of writing it out in England. Okay, so how can we use this to calculate the demand? Well, scientific calculator again makes our life much easier. So I can type in everything in one, and then the answer will come up. If I didn't have a scientific calculator, I would need to do the multiplications individually first, and then I would need to use the additions and the subtractions accordingly. But with the scientific calculator, I can just type it all in one go. So 2,500 minus 0.4 times 50 plus 0.5 times 3,000 plus 0.3 times 45. And the final answer should be 7987 over 2. Again, this is a fraction which we can't really use because in economics we're working with demands, so fractional demands don't really make much sense. So this would actually be 3,993.5. Now again, if we think about it in real life terms, we can't really demand half of a product. So strictly speaking, in many cases, this would be more like 3,994 quantities that we demanded, because obviously you can't have half a product of something. So the next topic I'd like to cover is quite important in economics, which is the percentage calculations. So just quickly go through some very basic percentage calculations. So what is 17% of 350? Well, we know that 17% is 17 out of 100, or you might recall from high school that it's also the same as 0.17. So if I wanted to calculate the 17% of something, the quickest and easiest way is to do 0.17 times 350. And you can do this with any kind of percentage. Just divide the number by 100 and then multiply that by the amount that you want to find the percentage of. Again, pick up the scientific calculator for it and just type in 0.17 times 350 and press the SD button to get the exact numerical amount instead of the fraction, so it's 59.5. So if it was money, 17, and let's say you needed to pay 17% tax, the tax you would pay for this price would be £59.50. Another type of calculation that sometimes comes up with percentages is when you need to find out what percent is 45 of £75, for example. So what percent, if you want to know what is the percent, you need to know what is the amount that represents the percentage, what is the full amount in the scenario. So in this case, I want to find out 45 as a percentage of 75. So 75 is the total amount, so the partial amount over the total amount, and because it's a percentage, we need to multiply this by 100. So again, having the scientific calculator makes our lives much simpler. Type in the fraction, put the 45 at the top, use the arrow to come down, type in the 75, use the arrow to come out from the bottom of the fraction, type in the times 100, and the answer here, nice and easy, 60%. So that was the second calculation. Now, it's very important to be able to calculate percentage change. So the price of a product changed from 55 to 57. What is the percentage change? So percentage change, by definition, is the final amount minus the initial amount divided by the initial amount and then multiplied by 100 to change it into percentage. Using symbols of mathematics, I could write it like x2 minus x1 over x1 times 100. So let's look at our question again. What is the initial amount? The initial amount is 55. The final amount is 57. So what is this £2 change expressed as a percentage? So 57 minus 55 divided by 55. So that gives me, again, using the scientific calculator, fraction 57 minus 55, come down, divide by 55, and then times 100. So times 100 equals, again, I've only got the fractional answer, so to find the decimal, I need to press the SD button, and that gives me 3.63%. So that's a very small percent, but because it's a positive, I know that this is a positive price increase. Similar question, the last one on the percentages. The price of a product changed from 75 to 67. What percentage change is this? Well, the initial price in this case now is 75 and the final price is 67. Now when we look at this, this gives me a price drop. So I'm expecting a percentage change of negative, not positive, because now it's a negative change in here. So the percentage change then will be final amount, which is 67, minus the initial amount, which is 75, divided by the initial amount, which is the 75. So calculator again, fraction 67 minus 75 over 75 times the 100 again. To get the percentage straight away. Now fraction, so change that into decimal. So that gives me minus 10 point, rounded to 1 decimal places, 7%. So when the price dropped from 75 to 67, that is equivalent to a 10, more like 11% price drop. Another quite common percentage calculation, which is more useful for your own purposes, it's not necessarily just for economics, is usually your final grade is given as a combination, percentage combination of a midterm exam or an assignment or a project work and your final exam grade. So, for example, for microeconomics for business, your final grade is 30% of your midterm plus 70% of your final exam. So how can we use this calculation? What does it actually mean? So let's say that John has achieved 65% in the midterm and he got 55% in the final exam. So what will be his grade? Now 30% is 0.3 and 70% is 0.7. So of the midterm exam, only 30% of it adds to the final exam. So that will be 0.3 times the 65% plus 0.7 times the 55%, which was the final exam. So again, using the scientific calculator, 0.3 times 65 plus 0.7 times 55 will give you an overall mark of 58%. So make sure that you don't achieve a smaller percent in your final exam, because that has got a higher weighting. So even if you do very well in the midterm, your final exam, because that's a higher weighting, can bring your score down. So make sure that you focus on your final exam as much as you focus on your midterm. Now let's look at the negative numbers, because the negative numbers are quite important for the following concept, which is elasticity. So before we go into the negative numbers, let's recap the number line. Okay, that is just a straightforward line with a 0 in the middle, and anything that is left from the 0 are the negative numbers, and on the right from the 0 are the positive numbers. Now in everyday terms, you can think about positive numbers as funds, money, and negative numbers as debts or credits, money that you owe to someone. So I have got positive 1, positive 2, positive 3, and further down I've got negative 1, negative 2, negative 3. Now obviously the bigger a positive number is, the higher its value. So if you have £3, you have more than £2. But what's going on the other side? When do I have more? If I have £1 debt or if I have £2 debt? But if I only owe £1 to someone compared to £2, I have got a smaller debt, which means that I have got more in negative 1. So when I'm comparing the numbers, the negative numbers, the closer they are to 0, the higher their value is. But with the positive numbers, the further away they are from the 0, the higher their value is. And that is simply coming from the fact that as you're going from left to right on the number line, the values of the numbers are increasing. So -3 is less than -2, and that is less than -1, which is less than 0. That's less than positive 1, that's less than positive 2, and that's less than 3. So what I suggest that every single time you look at the negative numbers, slow down and think, because if you're not very familiar with the numbers, the negative numbers can trip you up a little bit. So let's look at this number sequence. I've got 6.7, then the next one is minus 1.3, then 0.25, then minus 1.07, then 6.77, and then I've got minus 0.25. So the question is here, how can we order these numbers into increasing order? So obviously when I'm looking at the number line, the negative numbers are smaller, they represent lesser values than the positive numbers. So obviously one of the negative numbers will be the smallest. These are the negative numbers. So these will be the smallest, and the positive numbers will be the biggest. So out of these negative numbers, which is the smallest? Or rephrasing the question, when do I owe the most? When I owe these amounts. So when I owe £1.30, do I owe more than less than when I owe £1.07? Well, £1.30 is a bigger amount than £1.07, so minus 1.3 is the smallest of all of these numbers. Then the next one is minus 1.07, and the biggest of the negative numbers is the minus 0.25. There are no more negative numbers, so what I need to look at now is these are the positive numbers. Which one of the smallest out of these three? Well, 670 or 677 are quite big amounts, so therefore the 0.25 is the smallest. But which one is bigger out of these two? Well, if I've got £6.70 or if I got £6.77, the difference is not huge, but still the 677 is the highest of them all. So the next one up in the order will be 6.7, and then comes the 6.77. The last part, before we move on to elasticity, is to be able to compare numbers and decide if they are bigger or smaller than -1, because elasticity has been classified into different things, elastic, inelastic and unit elastic, depending on their relationship with -1. So when I want to compare numbers, if they're bigger or smaller than -1, this is -1 here in the number line. Anything that is on the left of -1, that will be smaller, and anything that is bigger than -1 will be on the right side of -1, so these ones are bigger. So let's look at these individual numbers. I'm going to put in another number here, 0, and probably +1. Could be quite useful to see on the number line as well. So let's look at these individual numbers. The first one is -1.2. Now, here on this side, I have got the negative numbers between -1 and 0. Numbers like -0.5 or -0.3. In here, I would have got anything that is smaller than -1, or would have something like 237, -2, -3, -7. So when I look at the -1.2, that would be somewhere around here. So therefore the -1.2 is smaller than -1. The next one is -0.7. Whereabout is -0.7 on the number line? But that is between -1 and 0 in here. So that is somewhere around here, -0.7. So that is on the right hand side of -1, so this would be bigger than -1. -0.07, that is somewhere around here, that is very, very close to 0, but it's still below 0 because it's a negative number. So that's again bigger than -1. Minus 3.4 is the next one in the line. Minus 3.4, so this is minus 1, that would be minus 2. Minus 3 is somewhere here. So minus 3.4 would be somewhere around here. That is far below minus 1, so that's again smaller than minus 1. Look at 2.1. So here is positive 1, somewhere here is positive 2, so positive 2.1 would be somewhere around there. Now, any positive number will always be bigger than negative 1, so anytime you see a positive number, you can straight away say that yes, this is bigger than negative 1. So that's true for 1.2 as well, which would be somewhere around here on the number line. And the last number to look at is minus 3. So minus 3 would be somewhere around here, and that is still smaller than negative 1. But how do we show this using the symbols for smaller and bigger? So I'm just going to pick up a few of them. So minus 1.2 is less than minus 1, but minus 0.7 is bigger than minus 1. 1.2 is also bigger than minus 1, and minus 3.4 is smaller than minus 1. So be aware of that, the way of the bigger or smaller than symbols. One way that I can remember is that the symbol is always open towards the bigger amount. So it doesn't matter which way you're placing them, make sure that it always opens towards the bigger amount. And obviously, if you only owe £1, you have got a higher value, you have got a bigger wealth than if you owe £3.40. Now, I hope that with these negative numbers, we are now ready to look into the elasticity. Now, there are three types of elasticities, and the concepts and the definitions you really need to learn and really need to be aware of how to calculate them. So the three types are the own price elasticity, which is usually referred to as EPQ. Then the other one is the income elasticity, which is referred to EMQX. And the cross price elasticity, which is usually referred to EPYQX when you're comparing elasticity between two products. Now, as I mentioned at the previous slide, negative numbers come into elasticity quite a bit, so let's see how we can use the negative numbers in elasticity calculations. So there are a few ways of calculating elasticity. The own price elasticity is calculated by the percentage change in quantity divided by the percentage change in price. And if you have got that formula, you break it out what the changes are, then you will find that it can be rewritten as a slightly different format. So the EPQ can also be calculated by price over quantity times the change in quantity divided by the change in price. So depending on what information is given to you, you would use one formula or the other. Now, the change in price, be aware is that it's slightly differently calculated than we would calculate a simple percentage change. So the percentage change in quantity is still the final quantity minus the initial quantity, but now you divide it by the average. Same for the percentage change in price. But how do we calculate the price average or the quantity average? So the Q average is equal to the sum of the two quantities divided by the number of quantities, which is 2, and the price average is calculated similarly, the sum of the two prices, again divided by 2, because when you're calculating the average of two products, you are dividing it by 2. One more important thing, and this is where the negative numbers come in, that when you're talking about elastic, inelastic or unit elastic demand, then the own price elasticity is either bigger or smaller or equal to -1. So you will talk about elastic demand if the own price elasticity is less than -1, you're talking about inelastic demand when the own price elasticity is bigger than -1, and you're talking about unit elastic when the own price elasticity is exactly -1. So that's why we looked at comparing numbers to -1 in the previous slide. So let's look at some exact calculation questions. So what is the own price elasticity? So I need to be able to calculate EPQ, that's what I need to find, of chocolate if quantity demanded for chocolate falls by 7% when price was increased by 12%. So quantity demanded, so that is the percentage change in quantity, and it falls or decreases are negative change, so we have got -7% in the percentage change of demand. And when the price changed, the price change was increased, so it will be a positive change, and that is 12%. So the formula is up on the board. So what you can see here now is you just need to substitute the right quantities into the formula. So at the top will be the percentage change in quantity, and at the bottom will be the percentage change in price. So the own price elasticity therefore will be -7% over 12%. So scientific calculator again. Fraction -7 come down to 12 equals, so the own price elasticity is -0.58. Next question is chocolate elastic, inelastic, or unit elastic? Okay, so remember, elastic was when EPQ is less than -1, inelastic when EPQ was bigger than -1, and unit elastic is when EPQ is exactly -1. Now, looking at our answer, we can say straight away that it's not unit elastic because it's not exactly -1. Now, the question is it smaller than -1 or is it bigger than -1? Well, this is closer to 0. So this is actually bigger than -1. So what we have here is an inelastic product. Let's look at another example which is slightly different. Again, we will make use of the own price elasticity formula, which is the percentage change in quantity divided by the percentage change in price. So what we know now is that the own price elasticity is -1.2, and the question is what will happen to demand. So what is the change, percentage change in demand, if we know that the price of the apple increased? So increase is positive change, so we've got the positive 20% change. Looking at this formula, let's put in the exact numbers and see how we can deal with that calculation. So own price elasticity is -1.2. That has to be equal to the percentage change in quantity, which we don't know but want to be able to calculate, divided by the percentage change in price, which is 20%. Well, that's a relatively simple formula. All we need to do now is multiply up by the 20% both sides, and we'll be able to calculate the percentage change in quantity. So -1.2 times 20% will be equal to the percentage change in quantity. So call the scientific calculator. -1.2 times 20, that is equals to -24% is the percentage change in quantity. What does it mean for us? Well, it means for us that when the price increased by 20%, the demand for chocolate will decrease by 24%. One more example, and it's still around the own price elasticity. So EPQ equals percentage change in quantity divided by the percentage change in price. in the question we know that Fizz Pop's own price elasticity is minus 1.4. Question is now, what will happen to the price, not to the quantity as in previously, but what will happen to the price if demand fell by 5%? So the percentage change in demand fall, so this is a negative change, and by 5%. Use these numbers, put them back again in the formula, and try to see what we can do. Minus 1.4 is equal to minus 5% divided by the percentage change in price, which we will need to be able to calculate. So, to calculate the percentage change in price, what I need to do, I need to multiply up by the percentage change in price, but then at the same time I will need to be able to divide it down by the minus 1.4. So the percentage change in price then will be minus 5% divided by minus 1.4. So what will that give me? I know that negative divided by negative will give me positive, so I can just simply type in 5 over 1.4. So that is 3.57 to 2 decimal places. So which means that as demand fall by 5%, price will increase by 3.57%. Now, one last example around own price elasticity, which is slightly different. So EPQ equals the percentage change in quantity divided by the percentage change in price. So the price of laptop increased from 500 to 580. So the original price or starting price of the laptop was 500 and the final price become 580. Demand for laptops hence fell by 10%. So that is the percentage change in quantity fell, decreased, so that's negative, and 10% the exact amount. The question is the own price elasticity. Now, to be able to calculate the own price elasticity, we need the percentage change in price, but we only have got the starting and the finishing price. How can we calculate the percentage change? Remember that a few slides ago I showed you that the percentage change in price can be calculated by final price minus initial price divided by the average price. Now the average price was nothing else but the two prices added together divided by 2. So with using the exact numbers, the percentage change in price then can be calculated as 580 minus 500 over 580 plus 500 divided by 2. Now, here again comes in the usefulness of a scientific calculator. Without a scientific calculator, what I would need to do, I would need to calculate the average first, then the difference, and then divide them. But with the scientific calculator, I can just put it all in once. I need a fraction. On top of the fraction, I need 580 minus 500. And at the bottom of the fraction, I need another fraction. So I'm going to press the fraction button again. And at the top of the bottom fraction will be 580 plus 500. Come down again, put the 2 in, then come out all of them, and then hit equal. So that gives me 4 over 27, which is equal to 0.148, which is roughly 0.15, and that is exactly 15%. Why do I know it's 15%? Because every time I need to convert something into a percentage, I just need to multiply by 100. So the percentage change is 15%. So go back to the original calculation, which is the own price elasticity. Now I have got the percentage change in the price, which is a positive 15%. So the own price elasticity therefore will be minus 10% divided by 15%, and that gives me minus 10 over 15 minus 0.67 to 2 decimal places. When it comes to elasticity, on-price elasticity isn't the only type. Sometimes you might need to calculate the income elasticity. And the income elasticity, which is EMQX, is calculated by the percentage change in quantity, but in this case now I'm dividing it by the percentage change in income. So basically I'm actually testing here is how sensitive the product is to income changes. So let's look at an example. If the income elasticity for champagne is 0.6, so I know that EMQX equals 0.6, then what will a 30% increase in income, so that's the percentage change in M being equals to 30%, lead to in the demand of champagne? So what is the percentage change in demand of the champagne? So put the numbers into the formula. So 0.6 is equal to percentage change in quantity of X over the 30%. So again, to calculate the percentage change in QX, I just need to multiply it by the 30. So 0.6 times 30. That gives me 18%. So a 30% increase in income will lead to an 18% increase in demand, given that the champagne's income elasticity is 0.6. Now let's look at the last example in elasticity, and this one's also an income elasticity question. Now, you are the manager of a supermarket and know that the income elasticity of organic butter is exactly minus 0.8. So EMQX is equals minus 0.8. Due to the recession, you expect incomes to drop by 20%, which telling you that the percentage change in income equals minus 20%. How should you adjust your purchase of organic butter? Well, what will happen to the demand? That's the question in here. So, should you order more or should you order less? So let's put the numbers into the formula and let's see what they tell us. So minus 0.8 is equal to the demand that I don't know divided by minus 20%. So similarly to the other case, I need to multiply up. Negative times negative will give me positive. So 0.8 times 20 will give me positive 16%. So what it means, it's because of the elasticity, the income elasticity of organic butter, even though there will be a drop in income, I still expect an increase in demand. Okay, so be aware of that. Depending on the elasticity of the product, sometimes a drop in income could still lead to an increase in demand. Now we came to the last topic of this video tutorial, and this last topic is how can we work with tables. There will be a few types of questions like this, probably towards the further lectures. You might have not come across with this yet, but I'd like to expose you to some calculations, some very basic calculations with tables. You might want to fast forward this video or just stop the video here and come back to this once you have gone through the theoretical background for these kind of calculations, so it would make more sense to you. So, question is, compute the monopolist's revenue, marginal revenue, and marginal cost. Please show the formulas you have used to reach your results. So first of all, we need to be able to calculate revenue, marginal revenue, and cost. And for those, we need to know the correct formula. Now, revenue is always calculated by price times quantity. And the marginal revenue is nothing else but the change in total revenue divided by the change in quantity. And by total revenue, we mean revenue here. And the marginal cost is the same as the change in the total cost divided by the change in the quantity. Now, first of all, when we need to calculate the marginal revenue, we will need to know the change in total revenue. For that, we need to know the revenue first. So, the revenue, or total revenue, is always price times quantity. Now, we've got the price, we've got the quantity, now we just need to calculate the price times quantity. So, 20 times 7. So, the total revenue here would be 140. The total revenue here would be 19 times 8, which is 152. In this case, 18 times 9, which is 162. 17 times 10, which is 170. And 16 times 11, which is 176. Now I've got all the total revenues. Now, to be able to calculate the marginal revenue, I need the change in total revenue divided by the change in quantity. Now, the change in total revenue will be total revenue later minus total revenue now. And the change in quantity will be the quantity later minus the quantity now. For this kind of calculation, I don't know what was the total revenue before. So I will not be able to calculate the marginal revenue for price 20 and quantity 7. But I will be able to calculate it for this combination. So the change in total revenue for this part will be 152 minus 140. And that needs to be divided by the change in quantity. Now the change in quantity will be 8 minus 7. Well, that's just 1. And if I look at the change in quantity is always 1 for every single one of these rows in the table. So I will always have to divide by 1. But dividing by 1 makes no difference. So the marginal revenue in this particular case, when the quantity only grows by 1, will always be just the change in the total revenue. So what's the difference between 152 and 170? Sorry, 152 and 140 is 12. So the marginal revenue is 12 for this particular price and quantity combination. How would that differ in here? So the change in total revenue now would be 162 minus 152, and I would need to divide that by the change in quantity, which is 1, because 9 minus 8 makes it 1. That will be 10. 162 minus 152 is 10. 10 divided by 1 gives you 10. The next one, 170 minus 162, again divide by 1. The difference between 170 and 162 is just 8. And the last calculation, 176 minus 170 divide by 1. Again, remember, 11 minus 10 makes 1. That's the change in quantity. And anything divided by 1 just gives the same amount. 176 minus 170 gives me 6. 6 divided by 1 is 6. So that was the marginal revenue. But how do I calculate the marginal cost? Well, the marginal cost will be the change in total cost. And the change in total cost, again, will be the later total cost minus the earlier or now total cost. So again, I can't really calculate the total cost in here because I don't know what was before. So for this, the total cost cannot be calculated. Therefore, the marginal cost cannot be calculated either. So I can calculate the marginal cost first for this row. So the total cost, the change in total cost is 45 minus 36, and that again needs to be divided by 8 minus 7. Well, change in quantity, just like in the marginal revenue calculations, always 1, because the quantity only grows by 1. So I will have to do the division by 1. So that will be just equal to the difference. So what's the difference between 45 and 36? Well, that is 9. 9 divided by 1 gives me 9. So the marginal cost for the next row is 54 minus 45 divided by 1. Again, 9 minus 8 gives me 1. So 54 minus 45, that's again will be 9. The next one is 63 minus 54 over 1 again, because 10 minus 9 gives me 1. 63 minus 54, that's 9. And the last one is 72 minus 63 divided by 1. And surprise, surprise, that is also 9. So as I mentioned at the beginning of this slide, you probably want to revisit this video once you have a little bit more understanding of how these revenue and cost tables work. And the last thing I would like to talk about in this video, again, is something you might have not covered just yet. And this is about strategies and Nash equilibrium. But I'm not going to go into much details about how the equilibriums work. I just want to make sure that you understand how to read these tables, because I came across with quite a few students who got confused about what number belongs to whom in these types of tables. So here's the scenario. You run a company, and the company you are competing against also producing similar products. The question is now, should you advertise or should you not advertise? When would you get a higher profit? What would be better for you? Now, before we go into the nitty-gritty parts of finding out how one company reacts to another company's strategy, what I want to make sure is that you know how to read these tables. Now, as you can see in here, there are number pairs. These numbers are the so-called ordered pairs, which I already mentioned at the very beginning of this video. How to read this table? This is me, this is my company, and I can either advertise or don't advertise. And this is the rival, and the rival can again advertise or not advertise. What's important in here is that in all of these ordered pairs, whoever is on the left-hand side is always the first number, and whoever is on the top is always the second number. So basically, in this table, for this particular scenario, the first number is always my company, and the second number is always the rival company. So it means that in this particular scenario, I owed 5 million, let's say, and my rival also earns 5 million. But in this scenario, I owe 1 million while my rival owes 15 million. Similarly, the other two. Now, and this is where the different rows and different columns come in. This is me advertising. So this scenario, these two number combinations in here is when I advertise, and my rival either advertise or don't advertise. And in this scenario is when I don't advertise and my rival is either advertising or don't advertising. So what is going on in here? If both of us are advertising, both of us earn 5 million. If neither of us advertises, we both earn 10 million. Whoever decides not to advertise and the other one is advertising, the person who's not advertising only gets 1 million, while the person who is advertising gets 15 million. So in this scenario, my company doesn't advertise, but the rival company advertises, because that is in the cross-section of these two. And that means because I'm the first number, I only owe 1 million, and because the rival is the second number, they earn 15 million. However, in this cell here, I advertise, so I earn 15 million, and my rival doesn't advertise, so they only earn 1 million. So whoever decides not to advertise and the other is advertising, there is a huge earning difference between the two companies. So what would be your tactic to maximize your profit, given that your rival can choose their own action? Which means that whatever I choose to do, the rival can go and choose their own tactic. So what is the two possibilities ahead of me? Okay, I can advertise. So if I advertise and my rival either also chooses to advertise, we both earn 5 million. But if my rival chooses not to advertise, I will earn 15 million and they will only earn 1 million. Now, if I decide to go to advertise, the best scenario for me would be if my rival would choose not to advertise. But the rival would be quite a silly company to not to advertise, because then they would only earn 1 million instead of 5 million. So if I'm going down to on the road of advertising, my rival will also advertise, because it's better for them to earn 5 million than to earn 1 million. So what happens if I don't advertise? Well, in an ideal world, if both of us would choose not to advertise, then we both would earn nice 10 millions. However, we are competitors. We all want to maximize our own profit. So if my rival knows that I'm not going to advertise, they're going to choose to advertise. Why? Because instead of 10 million, they could earn 15 million. And quite frankly, 5 million difference is a nice big difference. So they would definitely go for advertising, and I would lose out because I would only earn 1 million. So for me, the best choice would be to go with advertising. And I either earn 5 million or 15 million, depending on how quick my rival is at getting in there and starting advertising. Now, would this tactic be different if the rival would be choosing? Would the rival go with something different? Now, when you look at this table, the rival position is always the second. So the rival can either advertise, this would be these two scenarios, or don't advertise, it would be these two scenarios. So if the rival advertises, then again, there is still two scenarios depending on if I advertise or if I don't advertise. Obviously, for the rival would be better if I didn't advertise, but that would be no good for me, because if I don't advertise, I basically let the rival own the whole market and they would get a nice fat profit, and I would lose out quite a bit. So if the rival decides to advertise, I will have to go by advertising, because I want to maximize my own profits given the circumstances. Now, what happens if the rival decides not to advertise? Well, if the rival decides not to advertise, there are two scenarios here again. Either I'm earning 15 and he's earning 1, or we both earning 10. Well, again, just like in my case, which we went through previously, I'm not going to choose not to advertise, because if I don't advertise, I would only earn 10 million. But if I do advertise, I would earn 15 million. So that is a big difference there. So I would definitely go for advertising. And therefore, my rival would end up with only 1 million income or 1 million profit. So that is not a good tactic for them to use. So for them to maximize profit would also go for the advertising. In this first tutorial, which introduced you to the basic mathematical skills that are needed for microeconomics for business, we covered how to read mathematical notation. We went into some details about the delta notation, which refers to the changes. Then we looked a little bit about how to use the scientific calculator. We went into some details in percentage calculations. We looked at the negative numbers, which are very important for elasticity calculations. And then we spent some time on the different types of elasticity calculations. And in the last few slides, we looked at how to read tables. Now, as I mentioned before, these last two tables might not be very familiar just yet, but later on in the lectures, you will come across them, and then you might want to revisit this tutorial then. I hope you find these useful, and if you have further questions, you can contact me and book a tutorial.